Okie dokie, part 2. So I'll do the rest of it on here. So 4.2 homework continued. So state the domain and range of the piecewise function of the graph. Use interval notation. So interval notation is probably what you used. Wait. We used interval notation when we talked about domain and range. We also used it last year in IM1. So remember, when you're talking about domain, I got the wrong thing. So let's look at, I don't know what number this is. 13. I don't know why the number's not there. Domain has to do with your x values. So you're going from, actually, let me draw a line. It'll be straighter. So your x values from here, from that x value to this x value. So domain goes left to right. So our domain goes from -2, and you're going to use a bracket, -2, all the way to 7. So that's your domain. From x equals -2 all the way to 7. Then the range, let me do a line. Can I do a different color line? We'll see. Nope, still red. Okay, well, we'll just do red. Let me try that one more time. Line, line, okay. Your range goes from, oops, that wasn't straight, from that y value to, I should have done the bottom one first. Oh well. There we go. So y values, or sorry, range is y values, and you're looking low to high. So for range, what's my lowest y value? And it's -3. So bracket, -3. And I go all the way up to what? What's my highest y value? So the highest point on my graph. 6. Okay. That's domain and range. So you're going to do the same thing on number 14. You're going to do the same thing on number 14. If you wrote it in set notation, do I want to do it? Do I want to do it? Yeah, because that's just how we've been doing piecewise, is in set notation. So it would be x is greater than or equal to -2. I'll draw in my equal sign in a second, and it is less than or equal to 7. Let me draw in my equal signs. So x is greater than or equal to 2, and it's less than or equal to 7. So that's how you would write it in set notation. You could do the same thing with the range. Instead of having an x in the middle, you would have a y in the middle. Okay. Let's keep on going. For each of the graphs below, write the interval that defines each piece of the graph. Then write the domain of the entire piecewise function. So it doesn't want the domain of each little interval. Okay, it wants the domain of the entire graph, just like you were doing for 13 and 14. Write the domain and range? Nope, just domain. Write the domain of the entire graph. They give you an example. So they looked at number 14, which we can scroll back up. They looked at number 14. Okay? And they wrote the intervals. So the first interval was -3 to 0. Is that true? The first interval was -3 to 0. That is in fact true. X equals -3 and x equals 0. And then 0 to 4 is the next one. X equals 0 to x equals 4. Checks out. And then the last one is 4 to 6. x equals 4 to x equals 6. So that's what they're doing. They gave you a nice little example. Pay attention to your inequality symbols. What does that mean? It means, like we've been talking about, so they could have made this one equal to 0, but instead they did that one. That's fine. Sorry, that sounded really aggressive. That's fine. You can only do one though. These cannot both be equal to 0. And then the second two, these cannot both be equal to 4. Pick one. So I'll do 15. Does it matter? I don't think it matters. I'll do number 16 just to jump around. So number 16, interval 1, 2, and 3. And then we're going to write the domain of the entire thing. So interval 1, that's this guy. Interval 1. What is the interval for this one? Where does it start? Start with that. Where does it start? And remember, we're using x values. If we scroll back up, these are all values of x. Okay? We don't care about the y's until we don't care about the y's unless you're doing range. So, or if you're trying to find the slope. Okay, sometimes we care about the y's, but right now we don't. So it starts at -5. X is greater than or equal to, I'll add it in a second, to -5. And then where does interval 1 end? Looking at the x values. The interval 1, we're talking about this piece of the graph. When does it end? When does it change? Let me make it colorful. Hold on. That's fine. Interval 1 is talking about this piece of the graph. So it ends at -1, -2. When x is, wait, I think I said this wrong. X is greater than or equal to -5. X is greater than or equal to -5, and then less than, I don't want to change my input language. That was scary. Anyways, I forgot what I was doing. -2. So let me grab my pencil, draw in my little equal sign. So this one, x is greater than or equal to -5. You have to write it that way. Okay, let me click off of it. Nope. Okay, let me click off that way. There. This one is where you get to decide. Do you want it to be equal to -2 here or here? We don't have enough information, so it does not matter. It is your preference. I threw an accent in there somehow. I generally like to make it equal just because I don't know, but it does matter. It does not matter. So I'm going to do that. All right, let's do the second section. So go ahead and look at the second section of the graph and try and write the interval for it. Okay, so this is the second section. There it is. We match it. Boom. So this is -2. And then because I made the first one equal, this one is not going to be. Okay. Because I made the first one equal, this one is not going to be equal to. So x is greater than -2. Oops, move up a little bit, cursor. Work with me. It doesn't want to work with me. All right, fine. Fine, it'll just be slanted. It's fine. It's fine. And then x is greater than, less than, greater than -2 and less than what? When does this interval stop? When does the second piece stop? It goes from -2, x equals -2, and the corresponding x value is 1. Once again, you can either put it equal to here or it'll be equal to in the next one. I like to do equal to here. Okay. All right. Interval 3, we're going to run out of room. I'm going to do it over here. So interval 3. Let's make it a different color. How about orange? I don't give orange enough love because I really don't like it that much. So interval 3. Try and write the interval for the third and final part of this graph. Which is right here. Okay. So I'm going to do it right here. 1. So x is greater than 1. I made it equal to there, so it cannot be equal to here. But you could switch it if you want to. You can make it equal here and not here. But make sure it's only equal in one of them. And then it is less than or equal to, I'll draw it in a second, 2. So it goes from 1, x equals 1. It goes from x equals 1 to x equals 3. All right, we're going to draw it in. Oh, that got away from me. We'll see how bad that is. You can still tell it is. It's fine. So those are the intervals. Now you're going to write the domain for the whole graph. Using interval notation, we can use interval notation on the domain if it's continuous. It is continuous. How do you know if a graph is continuous? I could trace this graph and I would never have to pick up my pencil. Okay, that's one way to tell if it is continuous. You never have to lift up your pencil or your pen or your cursor, right? I can trace this whole graph without picking it up, which means it's continuous. There are no gaps in it. There are no holes. It's continuous. So we can write it in interval notation. Oops. Lowest x value to the highest value. So now that you have your intervals written out, you could just go -5 to 3. And then make sure that corresponds with your graph. Domain, farthest left is -5. Farthest right is 3. You could also write it in set notation. So it would be -5, x is greater than or equal to that, and x is less than or equal to 3. So it's really good to know how to write it both ways. So this is interval notation, this is set notation. They tell us the same thing. Oof, okay, that was 14. So you have to do the same thing on 15. And then 17. 17 is kind of a weird one. So it says, so far you've only seen continuous piecewise defined functions. They've all been continuous so far. But piecewise functions can be non-continuous. It's also called discontinuous, but okay. In fact, you've had some real life experience with one kind of non-continuous piecewise function. The graph below represents how some teachers calculate grades. Finish filling in the piecewise equation, then label the graph. Okay. Let me get this and let's make it, let's make it not orange. Blue. So, I know this looks strange. What you're doing is you're going to fill in the values. So teachers give you a letter grade, generally, A, B, C, D, or F, right? So if you have an F, usually it's your grade percentage in that class is a 0 to, we'll do 0 to 60. Okay. And then you would fill in these corresponding values. So D is a 60. Sorry. 60 to a what? And then C is a what to a what, all right? And then A is generally 90 to 100. So finish filling in the values over here. So that's filling in the piecewise function. Then label the graph with the corresponding values. So generally, this one, the 0 to 60, or whatever you chose here, this is an F. Okay. And then 60 to whatever, the next one's a D. All right, and keep going up like that. So that's what they want you to do. This is called a step function. A step function. Step function. See how they're like steps? It's not continuous because as soon as you hit like a 60, you automatically bump up to the next grade. And then you automatically bump up to the next grade. You don't have everything in between. There's nothing between an F and a D. It's like you either have an F or you have a D. This is why they're not continuous. So you can like step up. That's probably why it's called a step function, because they look like stairs. Okay. Number 18 and 19 is very similar to, well, all right, I'm not going to write the equations for you. I think you can do that. What I'm going to tell you is these are not continuous. I cannot draw this graph without picking up my pencil. This is a discontinuous graph or a non-continuous graph. It's not continuous. So the only thing that's going to change is figure out your equation like normal. So the equation for this first one and the equation for the second one. So you're going to have two equations. 1, 2. You're going to have two separate equations. And you're also going to have two separate domains. So let's look at this one. The domain for the first one. Oh, I don't think I meant to do a text box, but I guess that works. The domain for the first one is the farthest left x value is 0. So 0 is less than or equal to, I'll add that in, x, which is, sorry, it's greater than or equal to 0, and then it's less than or equal to, goes from x equals 0 to x equals 4. All right, let's see if it'll let me draw on these. I don't know if it will. Oh yeah, easy peasy. There we go. So that's the domain for the first one. So x is greater than or equal to 0, and then it's also less than or equal to 4. This time you have to put equal to 4 here because look at the next one. The next one, if I'm writing so find the equation of this line, and then if I'm writing the domain, it starts at, oh, it does start at 4. Did I do that wrong? 1, 2, 3, yeah, I did. It's like it shouldn't have ended up like that. Hold on. So this is 3. My bad. X is 0, 1, 2, 3. There we go. Sorry. Oh, got rid of my little. Oops. Well, there you go. There we go. X is greater than or equal to 0, and then less than or equal to 3. This is a 3. Then your second one starts at 4. and goes to 5, 6, 7, 8. So this is discontinuous. There are no values for x between 3 and 4. There's nothing there. There's no values for x in between those. Okay, so at 19, you're going to do that. And then the last three are review from Unit 2, shifting parabolas, transforming parabolas, that's the word. So I'm not going to graph it for you, but I'll do number 20. I'll write the equation for number 20. Actually, I kind of like that text box better. We're going to do that. There. So your normal parabola is y equals x squared. I think they tell you that. They tell you that? Yes. They use f of x. So what are we doing here? So we shift it left 3, stretch 2, stretch vertically 2, reflect, and shift down 5 units. All right, that's a whole lot of things. So remember, you can write this in vertex form. I would. So f of x equals a h squared plus k. Okay, that's vertex form. So a is your stretch. So we're vertically stretching by 2. And we are also reflecting. So we are reflecting. So that means this is negative. Then we're going left 3 units. So that's going to be to the left. So that's plus 3 squared. And then down 5, minus 5. So that would be your equation. And then now that you know those transformations, you can graph your parabola. So you're doing that for 20, 21, and 22. Or you can do your equation first, and then you know your vertex is going to be -3 and -5. So your vertex is going to be -3, -5. And then you can substitute points in on either side of that to graph your parabola. Okay, I think that's it. Whew, I will let you go as soon as I pause this.